Sorry, first reference drawings. Load calculations. Collection of machines. Collection of machines. Location of machines. And selection of air. Selection of air terminals. So air terminals are mainly two types. Okay, most commonly divided into two types. Diffusers and grills. Diffusers round and square. This is round. So this is how square diffuser looks. Okay, so square diffusers again they are into So we have only one way, two way. It will throw the air only in through two way. Three way. Four way. One way. four way. So most commonly in one way, two way, three way, and four way, we use two way and four way. हमें two way use करता है और four way use करता है. So two way we use in the applications like corridors where the length is very long and width is very small. So at that conditions we use two way, and in every regular application we use four way. So grills are in rectangular or linear shape. So application, residential, commercial. Commercial or industrial. So these are the applications. Application residential or commercial, here commercial or industrial. So not only the type of application, okay, not only the type of application, type of false ceiling also defines what type of air terminal we need to use. Types of false ceiling. Plain or flat false ceiling. Plain or flat false ceiling. If false ceiling is plain or flat, so we have option to use diffuser, diffuser. So we have a second one is grid false ceiling. So if the false ceiling is grid false ceiling, we have option to use, we need to use So we use stepped false ceiling. So here we can use only drill. So the stepped false ceiling will be like this. Okay. So this is grill. Okay. So coming to the location of machines, already we discussed. If we have a AHU, AHUs will be placed in the AHU rooms. Okay, AHU will be placed in the AHU rooms, or AHU will be placed on the rooftop. If AHU room is not there, will be placed in the rooftop. Okay, and FCUs will come in the plenum space or attic space. Okay. Make a note of this. What? Is it done?
Yes. Certain. Certain. Certain.
Okay. Now what you need to do is you need to make a note of these values. Selection, outlet size, quantity. That means diffuser. This is a diffuser size and this is grill sizing according to the CFM.
Okay.
So here 6 inch by 6 inch. This is a square and round will be dia 6 inch. 9 inch by 9 inch and round will be dia 9 inch. Like that it will be there. Done.
So 1 minute. Certain.
Okay, 1 minute. So suppose this is a room. The size of this room is 40 feet by 24 feet. 40 feet by 24 feet. Now, in this room, how many diffusers I need to place?
What is the type of ceiling, sir? 40 by 24, na?
Yeah.
Which is 80, 960 SFT. So, what is the size? Any size you suggest, or we can take the size?
First, how many diffusers we need to have? Later, we'll discuss the size.
Sir, at first we have to calculate the room capacity, sir.
CFM, na, sir?
So
CFM.
CFM,
Got it. 960 by 400, that is 2.2. Two diffusers.
2 diffusers.
2.1 actually getting 960 divided by 400, na, sir?
Okay. So basically,
2.4 we are getting.
any diffuser, okay, any diffuser
Yeah, 2.4, yes.
can throw the air. Suppose this is the diffuser, right? Can throw the air six feet in one direction. Okay,
Irrespective of the size.
irrespective of the size. And 6 feet in one direction. Okay. So whatever the velocity we are maintaining according to that 6 feet. So total how much feet it is?
12.
12 feet. So what we do is we'll divide 24 with 12 and 40 with 12. So if you divide 24 with 12, how much it is?
2.
2. 40 with 12,
3.3.
3.3. So which we can't make equal distribution here. So we'll make it as 4. Next number. Okay. Now that means 24 को 2 parts करना है. So each part will be
12 by 40.
so 24 को 2 parts करना है. So each part will be 12 feet, right?
Well,
Next 40 को 4 parts करना है. Then each part will be
10.
10. That's it.
10.
So the process what I am doing is called as marking. this is called as marking. Okay. Now we'll find. Now there is a room in your room, sir.
Hmm.
We brought a fan which cost around 5,000.
Hmm.
So where will you place that fan inside the room?
Based upon the bed position, if it is a bedroom,
Suppose it's a normal hall or something. Center, right? Why you place it center?
Equal flow of the air.
Yes, it will throw the air in the all directions.
Hmm.
If you put in one corner, the people who are sitting in another corner will not get the air.
Yeah.
Right. Same here also, we'll find the center.
Hmm.
So you need to remember always the importance is given, okay, for the supply air terminals.
Okay.
Why? Because you are getting comfort air from the supply, right?
Yes.
So always important is given for the supply air terminals. Okay. So we have found the midpoint. Now how many points we got now? 1, 2, 3, 4, 5, 6, 7, 8. 8 positions we have, right? So
Yes.
that means 8 diffusers it will come. Divided by 8. So what is the value we have?
So 500.
500 CFM each. If it is 500 CFM each, what is the diffuser size then?
1.25.
Sir, diffuser size.
Diffuse size. Okay.
12 by 12.
12 inch, 12 into 12 inch.
12 by 12. When you come out of that calculations divided by 400.
Yeah, got it, sir.
Why? Because, see, I'll tell you the truth behind the calculations. Okay. So, this is the diffusers.
Hmm.
We place the diffusers.
Hmm.
So, what type of projects you deal, sir, Sandeep?
Hotels and clubhouses,
Okay.
IT offices.
Suppose if you get a project from DRDO or if you become a subcontractor of L&T, okay. So have you ever worked if you are subcontractor for Shapurji, Palanji, like that? Okay.
Okay.
They, so now I'll come to you. So this is machine. So a machine upper hai, but I am placing here. From the machine, I'll draw the line. I'll connect all the diffusers.
Basically, duct hai kada I think.
It's a duct, single line.
Yeah.
Okay, it's a single line. So this process is called a single line drawing.
Okay.
Okay. Now what I need to do, I need to take approval of single line drawing from the client, end user, whoever the consultant person is, POS, point of contact, POC. Okay. So from the point of contact, you need to take approval of this drawing. Then only we'll do the double line drawing.
Okay. Actual drawing.
Actual drawing. Why I need to make the confirmation is because I'll complete all the drawing. I'll do the duct sizing and everything. If the client tells us there is a change in this. So what he is doing? He is dividing this room into two parts now. Now again your design is going to change here.
Yeah.
So you need to resize all these things from here to here. Okay. Suppose if E changes here, anywhere, any small change can lead to work again. See, drafting is a part where we work bigger projects 3 to 6 months. Okay. Suppose if you want to design for a project like IKEA, how much time you need to drafting? Only drafting I am asking. Okay.
Around 2 to 3 months. Sir?
Yes, 2 to 3 months. So a single change may lead to the, again you need to work out for 15 to 20 days, right?
Okay. Yeah.
So that is the reason you take final approval. You take the sign or you draft a mail. Okay. You take you need to have an official approval. Then you need to start the double line drawing.
Okay.
Clear? Now I'll come to one point. So I have given double line drawing. Okay. I have given double line drawing now. Be with me. So they have taken the drawing to the site and they are executing the project. Now, like me, plumbing engineer also will give drawing.
Yeah.
Like me, okay, like me, firefighting drawings will come. Like HVAC, electrical drawings will come. Like HVAC, CCTV and security system drawings will come.
Yeah.
So every site engineer will be executing their projects on the site. Now, real time पे क्या होता है? Why? Because we may not be seeing the real time. Real time में there may be slight changes. Okay, somewhere I'll take a short radius elbow, but there is a beam or column coming. So what I do, short radius elbow instead of short radius elbow, site engineer will take instant decision and he'll make a long radius elbow. Okay. So there may be little changes in the site. Whenever there is a change in the site, on the site, that change will be given to the site manager or will be given to the consultant. Will give that change to the consultant. Now what we do, we change the drawing according to the correction done in the site. We'll update the drawing, right? Okay. So after updating all the drawings, so you'll get exactly what executed in the site, right? Exactly what they have executed on the site, that will be in the drawing now. Are you getting, Sandeep?
Yes, yes.
So that drawing is called as built drawing. Got it?
Yeah.
After making all the changes, after executing that. Now, so when you come to these are the normal projects, but आजकल technology भी बढ़ गया. Technology also evolved a lot in the industry. Okay, so we go with the coordination drawings now. Okay, so that coordination drawings is nothing but we give all our 2D drawings to the MEP design developer. That means MEP, Revit MEP में. So we give to the Revit MEP engineer. So what he do, that Revit MEP draftsman will convert all these drawings into the 3D layouts. Okay, after converting all these drawings into 3D layouts, whenever there is a clash between the two drawings, suppose I am running a duct and there is a clash between the pipes. Okay, sewer pipes. Okay, now what he will do, he will suggest a change. Here sewer pipe change karna hai. So when he suggests a change, we will change it, but we see whether it is affecting our calculations or not. Okay, so like that we'll make a clash free drawings and we'll check by using a Navisworks. Navisworks is the one of the software which is attached to the Revit MEP or Revit software. So Navisworks में we see in the 3D model, 3D design exclusively how it is looking for us. Okay, like that, the technology award, we are doing that process to make easier while executing the projects. Hope you are clear. Is it clear?
Yes, sir.
Okay. Next.
So Navis is free, sir?
No, sir. Paid only. That is also paid.
Okay.
Navis is to create the camera port views.
Okay.
Suppose you can see some projects, they'll show the 3D layouts, how if someone is walking inside the building, how it looks.
Okay.
The 3D layout is there, that like for that to render that videos, we use Navisworks.
Okay. Okay.
There are many softwares in the market. Navis is the one of them. That's it.
But Beam is there.
Yes. You may know many things among them.
Yes, sir.
You may know many softwares like that, right?
మైక్రోసాఫ్ట్ యూజ్ చేస్తాం సార్. అంటే ఒక మన డెన్మార్క్ కంపెనీతో వర్క్ చేస్తాం సార్ ఇప్పుడు.
ఓకే.
మైక్రోసాఫ్ట్ మీకు ఐడియా ఉంది సార్ ప్రోడక్ట్ హోలోలెన్స్.
ఏదండి?
మైక్రోసాఫ్ట్ హోలోలెన్స్.
ఓకే.
దాంతో కలిపి.
ఓకే. నెక్స్ట్ అదే చెప్తున్నా, మీకు ఎక్కువ సాఫ్ట్వేర్ ఐడియా ఉంటుంది, అది మీ వర్క్ బేసిక్ గా.
హెడ్ఎక్స్ అని అక్కడే కదా సార్ వచ్చేది.
అవునవును. నెక్స్ట్ ఇప్పుడు మీరు అన్నట్టు ఆల్వేస్ 1TR 400 CFM తో వెళ్తున్నారు మీరు ఇప్పటి వరకు.
అవును సార్. అంటే
యూ డిడెంట్ గెట్ ఎ ప్రాజెక్ట్ విచ్ క్రియేటెడ్ హెడేక్ టు యూ. ఒక ఎగ్జాంపుల్ ప్రాజెక్ట్ చెప్తాను నేను. సో దెర్ ఈస్ ఎ ప్రాజెక్ట్ విచ్ యూ గెట్ ఫ్రమ్ DRDO. ఓకే, DRDO లో డిఫరెంట్, DRDO అంటేనే రీసెర్చ్ అండ్ డెవలప్మెంట్, రైట్? వాళ్ళ ఆస్పెక్ట్స్ డిఫరెంట్ ఉంటాయి. ఒక రూమ్ ఏమో 18 degrees Centigrade ఉండాలి, ఒక రూమ్ ఏమో 20 degrees Centigrade ఉండాలి, ఒక రూమ్ ఏమో 24 people ఉన్న చోట.
ఓకే.
Now still you can't move with a thing called 1TR equals to 400 CFM. వెళ్ళచ్చా? లేదు. వెళ్ళలేదు. సో అక్కడ మీరు వెళ్ళినా వాళ్ళు ఏమంటారంటే దే విల్ ఆస్క్ యూ ఏ కంప్లీట్ ప్రూఫ్. ఈ లోడ్ క్యాలిక్యులేషన్స్ ని వాళ్ళు అడుగుతారు మిమ్మల్ని.
ఓకే.
కంప్లీట్ గా మీరు ప్రూఫ్ చేస్తేనే యు ఆర్ గోయింగ్ టు ఫస్ట్ లెవెల్స్ లో వెళ్తాం మనం.
ఓకే, ఇన్ టర్మ్స్ ఆఫ్ షార్ట్ లిస్టింగ్.
యా. సో ఫస్ట్ మనం ప్రాజెక్ట్ వచ్చేసిన తర్వాత ఫస్ట్ మనం ఏం చేస్తాం, లోడ్ క్యాలిక్యులేషన్ చేసి మెషిన్ స్పెసిఫై చేస్తాం. సో వాళ్ళ ఇంజనీర్స్ వెదర్ దట్ మెషిన్ ఈస్ క్యాపబుల్ ఆఫ్ దిస్ అనేది వాళ్ళు ఐడెంటిఫై చేస్తారు ఫస్ట్.
ఓకే.
అండ్ దే హ్యావ్ దేర్ ఓన్ SOPs. వాళ్ళు ఎలా ఇస్తారంటే ఒక బుక్ ఇస్తారు, హ్యాండ్ బుక్.
ఓకే.
అండ్ యూ నీడ్ టు ఫాలో ఎవ్రీ SOP దేర్.
ఓకే.
సో అందుకు మీరు, ఎందుకంటే ఇప్పుడు రాబోయే రోజుల్లో అలాంటి ప్రాజెక్ట్స్ కూడా రావచ్చు మీకు.
ట్రై చేస్తా.
యా, యూ నీడ్ టు బి వెరీ క్లియర్ విత్ దట్.
అండ్ ఐ వాంటెడ్ టు వర్క్ ఇన్ హాస్పిటల్ సార్. ఇప్పుడు దాకా చేయలేదు. ఐ థింక్ హాస్పిటల్ కూడా సేమ్ ఉంటుంది కదా సార్, ఐసీకి ఒకలాగా ఉంటుంది.
అవును, హాస్పిటల్స్ కూడా SOPs ఉంటా. నేషనల్ హాస్పిటాలిటీ స్టాండర్డ్స్ అని ఒక బుక్ దొరుకుతుందండి. అది కరెక్ట్ చెప్తాను నేను.
ఓకే.
ఆ బుక్ తీసుకుంటే మీకు సెట్ అయిపోతుంది. మొత్తం డేటా మొత్తం ఆ బుక్ లో ఉంటుంది, హాస్పిటల్ ఎలా డిజైన్ చేయాలి అని.
ఓకే సార్. మీకు ఏమన్నా ఎక్కడ దొరుకుతుందో చెప్పండి సార్, కొనుక్కుంటాను.
చెప్తాను. అది ఆస్ట్రేనో ఇస్రో పబ్లికేషన్ లోనే ఉంది. నేను చూసాను ఒకసారి, చదివాను కూడా ఆ బుక్ ని. కరెక్ట్ 4 years 5 years అయిపోయింది. ఆస్ట్రే ఆర్ ఇస్రేలోనే ఒక సపరేట్ హ్యాండ్ బుక్ వస్తుంది, చిన్న హ్యాండ్ బుక్ వస్తుంది. అది విచ్ కాస్ట్ అరౌండ్ 200-250 రూపీస్. అది యా, అది నేను మీకు చెప్తాను. ఐ విల్ గివ్ దట్.
థ్యాంక్ యూ.
Okay, hope it is clear till now, right? Any doubt?
No sir.
Okay, so if you allow me 2 minutes, I will come to with another system and we'll go with the drafting of G+2.
Okay sir.
Okay. Yeah, before going to drafting today, The drafting will take more. I'll come with some other concept which can close within next half an hour. Okay. Now, yesterday in the previous sessions, we have discussed on the concept called duct shapes, right?
Yeah.
Which duct shape should be selected for which project? Which duct shape should be selected for which project is the major thing. So coming to the duct shapes. So which duct shape is more efficient? We have a square rectangle and a square rectangle and round duct. Which duct is more efficient?
Round 360 degrees, 6 feet, sir.
Now, my question is, Sir Noor Muhammad, Pranav,
Sorry, sir.
I'm not talking only with Sandeep.
No, sorry. We are listening actually.
Yeah, my question is, we have 4 different shapes of the ducts, right?
Yes, sir.
Among these ducts, which one is efficient for any type of project?
Rectangular.
Rectangular? Okay, good.
Yes.
Pranav?
Just a rectangle.
Rectangular.
Majority switches.
Let's do one small exercise, right?
Round 360 degrees లో 6 feet వస్తుంది సార్.
That we can manufacture according to the sheet.
అప్పుడు రౌండ్ దే బెటర్ కదా సార్, నాకు 6 feet 360 degrees వస్తుంది కదా.
చూద్దాం సార్ ఏది బెటర్, విల్ కంపేర్ ఇట్.
ఓకే.
మన ప్రాజెక్ట్ కి ఏది బెటర్, విచ్ వన్ ఇస్ బెటర్ ఫర్ అవర్ ప్రాజెక్ట్, విల్ కంపేర్ ఇట్.
ఓకే సార్.
So now I have a CFM of 10,000. Okay. Velocity 1500. Okay. So length of the duct. Twelve feet is a length. Okay. Now, so can anyone tell the round duct size in this case? Open your duct sizer, find out the round duct.
Yeah. 12 by 12, huh? No.
Round duct.
Yeah, 25 we have. 225 అంటే 1002. Oh, duct కదా, diffuser I'm saying. Yeah.
Duct sizer. I need
Yeah,
duct size.
yeah, okay, sorry, just. So flow rate is 1500. Sorry.
Flow rate is 1500.
Yeah.
CFM is 10,000.
Yeah.
Sir, equal diameter 35.
35.
How much?
35.
35.
36. Okay.
35, sir.
36.
Yeah, I got it. Yes, yes. Very, very true. Yeah.
Now same rectangular find out karo. So, wait. What is the friction you are getting here?
For the friction,
It lost.
friction factor is
0.7.
no, sir. Point not 19.
Yeah. Means frictions and headlocks. You are asking headlocks, right? Yeah. 0.07. 0.07. 0.07.
No, head loss is 89.778.
No.
Friction is 0.
0.07. Yeah, Sandeep. Yeah, 0.07. Actually, head loss.
No, here, if you see the friction factor is in 0.01.
No. My question is, after placing CFM and velocity, you'll able to see one head loss in between that.
Yes, is 0.76.
0.076.
0.77.
Yeah.
Okay. Okay, whatever. Okay, no problem. 0.7.
Now rectangle. For square find out karo.
Okay. 35. Sir, 32.
Same, 0.76.
32.
76. Yeah, same.
A rectangle with a height of 18 inch.
Same, 0.77.
That will 0.77.
Yeah, same. Yeah.
Height of what was you asking, sir?
Height is
18 inch, that size.
No, height.
18 inch.
18 inch.
Yeah, 62 by 18.
62 by 18.
Yeah.
Okay. So these are the different sizes of the ducts for the same velocity, right?
Yeah.
Now, so what is friction basically? This is head loss only. I didn't find total friction. What is friction basically? Friction equals to
The
how much?
amount of the
Basically,
air
friction is the opposing force.
Yeah.
So friction depends on the area. If area is more, the opposing force will be more.
Yes.
If area is less, the opposing force will be less, right?
Yeah.
So when we have more area, more contact area, we say surface area basically. We say more surface area leads to more friction. Okay. More friction leads to higher capacity of the
Machine.
pressure required. That means more friction. Suppose my point is, now this is one duct, right? And I need to take my air from this point to this point.
Yes.
So you need some pressure. Air आपने आप जाता है क्या?
No.
कुछ प्रेशर तो देना पड़ेगा ना. वो प्रेशर देने के लिए हमको इधर ब्लोअर यूज करते हैं बेसिकली. Getting my point?
Yes.
Now, if
Okay. Hello. Hello, Andy.
Can I proceed?
Andy. నేను మొన్న మీరు నెంబర్ అడిగారు, నెంబర్ ఇచ్చానండి.
Sandeep, please be on mute.
విండోస్ అడిగారు కదా.
Okay. So now I need to throw the air. I need to throw the air from this point to this point. So that I need some pressure. So that pressure is given by the blower, and blower runs on the motor. Now if contact area of this, the contact area of this, that means this contact area increases the surface area, that leads to more friction loss. When there is a more friction loss, you need to have a higher capacities of the blowers. When you have a higher capacity of the blowers, you need a higher capacity of the motors. Am I right?
Yes.
Yes.
Right. So now let's calculate. Let's identify the surface areas. Okay, let's identify the surface areas. So the surface area for this is pi dl, pi by 4, pi dl. Area is pi d into length. So first इसको इंच में कन्वर्ट करो 36 को. So 36 means 3 feet. So pi dl 3.16 into 3 feet into 12 feet. How much will you get?
36 into 3. 108 something, 108.112.
108.12.
No, sir, just calculate with the
113.76.
113.76.
76.
Surface area of
square.
pair is 2 into width plus height into length. 2 into 32 को फीट में कन्वर्ट करो फर्स्ट.
By 12. 32
plus 32.
2.6 plus 2.6, 5.2.
2.6 plus 2.6.
5.2. Okay, for 10.4 into 12, 124.8.
Next, same like that. 2 into width plus height into L.
So 62. 160.
160. Are you able to notice something here? What is the contact area here?
114. Yeah.
114. What is the contact area here?
160.
So here, when the contact area is 160, okay, when the contact area is 160, now, okay, you need more higher capacity of motor compared to this, right?
Yes.
Why? Because here friction is more. First thing. Next, one more thing you need to notice. Now I need to manufacture these ducts. I need more material, here or here?
Here 160.
160 consumes more material compared to this, right? If you are able to use more material here, is this profit for the company?
No.
Yes or no?
No.
ज्यादा मटेरियल दे रहा हूं, मुझे प्रॉफिट होगा क्या?
No.
सो कंपनी के लिए वो नुकसान, लॉस है. सो इनिशियल इन्वेस्टमेंट ज्यादा हो रहा है. सो इन्वेस्टमेंट ज्यादा हो रहा है, तो विल यू रेकमेंड दैट डक्ट? No. But still, why people are using rectangular ducts? आप किधर भी जाओ, मोस्टली रेक्टेंगुलर डक्ट्स ही देखते हैं ना.
Because the grills we get is more rectangular.
No, above the false ceiling we will have some sort of place only. Means
Yes,
clearance only.
Restricted space.
Plenum space.
This is the plenum space, right?
Yeah.
Suppose my प्लीनम पे 3 फीट दिया है, संदीप सर हमको 3 फीट आई प्लीनम स्पेस दे दिया. मैं 3 फीट में डक्ट बन सकता हूं क्या? अभी 3 फीट प्लीनम स्पेस है.
No.
ये 36 इंच है. अभी कितना ये? 36 एग्जैक्टली 3 फीट आई है, राइट? So can I directly take this duct to here, and how it looks is it will come like this, right? So can I use this duct here?
No.
No, right? I can't use this duct here. So there are some standards where I need to maintain 6 inch from the top and 6 inch from the bottom as a clearance space. Why? Because not only HVS, we have other services to run, right?
Yes.
To run other services, we need to have a clearance space. So to maintain this clearance space, we are restricted to use this duct now. हमको पॉसिबल है यही डक्ट के लिए ना.
Got it. All MEP services. Yeah.
So now ये डक्ट मैं लिया तो क्या हो रहा है, कितना लॉस हो रहा है. देखो 113 कहां पर है, 160 कहां पर है. So 160 square feet बनने के लिए 160 divided by 32 सोचो. How many sheets you required?
8 by 4 sheets, no, sir?
8 by 4 sheet.
32 means 5.5, around 6 sheets.
6 sheets चाहिए. और इधर
32 by means around 4.
4. So there is a lot of difference, right? सिर्फ 12 feet duct बनने के लिए आपको how many sheets you required here, how many sheets you required. So like that we won't be at like 12 feet. There will be a 800-900 feet of duct.
Got
In a project 800-900 feet total duct length आता है. तब कितना loss होता है? So when the client is restricting you with the space, we need to sit with him and we need to explain him really what is happening in the site. So this loss is not only a one-time loss. This loss is going to be a lifetime loss for the project, right?
Yes.
What is lifetime loss?
Why that blower machine speed and all?
Yeah, you need to have a higher capacity of the blower. As you need a higher capacity of the blower, you need a power. You need more power consumption. When there is a more power consumption, every month you will get a power bills, right? So what you need to do? You need to ask your client at least 18 inch, 20 inch के लिए पूछो और 24 inch के लिए पूछो. Even if you increase 10 inch, 5, 6 inch also, there you can create some difference, right? Am I right or wrong? If client allows us to increase 6 inch more,
Yeah.
even there we can create some difference, right?
Yes.
So that is the reason. This is where you need to select your duct shape. This is how the duct shape is defined basically. Am I clear?
Got it.
Next, some places there won't be any false ceiling. कुछ places auditoriums ऐसा कुछ places में false ceiling ही नहीं होता है ना. Then at that particular place, what type of duct will you choose?
Round only.
Round only. So round ducts are more efficient ducts. Okay. If you attend any interviews, the people who are freshers or 2 years, 3 years experience, most commonly they ask this question: how you select the shape of the duct? The shape of the duct is defined with respect to the restricted space provided by the client. That means restricted height we say. So if there is no false ceiling, I'll take round ducts. Why? Because round ducts are more efficient ducts compared to the square or rectangular, and round ducts will take less material manufacture round ducts compared to square or rectangular. It consumes less material as well as it has a less contact area, so that the running cost of the project will be decreased. Hope I am clear, right?
Got it. Yeah.
Yes, sir.
Yeah.
Yes, sir.
Next, how the thickness of the sheet is defined basically. How the thickness of the sheet is defined.
The length of the duct and also the depends on main branch and the trunk branch, sir.
The thickness of the sheet is defined okay. The thickness of the sheet is defined by using the width of the duct. Okay, the width of the duct defines the thickness of the sheet. ओके, सो थिकनेस, सो कल मार्केट में जाता है सर आप लोग, हाउ विल यू आस्क थिकनेस ऑफ द शीट? थिकनेस ऑफ द शीट हमें कैसा पूछता है?
1 mm, 1.2 mm. like that.
1.2 mm का शीट दे दो बोलते हैं मार्केट में.
No sir, kg, 24 kg, 22 kg.
Yeah, we define the thickness of the sheet by using a gauge number. Okay, we define thickness of the sheet by using a gauge number, right? So now width, thickness, gauge number. If the width is up to 30 inch, 30 इंच होता है तो हमें 0.63 mm का थिकनेस लेता है, विच इज क्या होता है 63 mm थिकनेस? गेज 24 होता है. ओके, गेज 24 इंडिकेट्स 0.63 mm विच इज 32 इंच से 60 इंच तक 0.80 mm. So gaze 22, 62 इंच से 90 इंच तक 1 mm directly, which is gaze 20, 19, 92 and above 1.25, which is case number 18. Is it clear? This is how we define thickness of the sheet. When the thickness of the sheet changes, the cost of the project also changes, right? Okay, so now why we need to choose a particular thickness for particular size of the duct? Sir, why can't I go with gauge number 24 everywhere? Right? ले सकते हैं, नहीं ले सकते?
नहीं ले सकते सर.
क्या होता है?
If it is, yeah, if it is big size, the sagging will be there and the vibration will be get more.
Yeah, it vibrates. Basically, it creates lot of sound. Why width कब बढ़ता है सर? Width कब बढ़ता है? When we have a higher volume of air inside the duct width भी बढ़ेगा, right? Duct width भी बढ़ेगा. So higher volume of air होता है तो तब उसका thickness भी मोटा होना है, so that it won't create that sound. Okay, so that is the reason thickness of the sheet is required. मैं 0.63 mm का thickness देता हूँ साइट पे. मोहम्मद इम्तियाज, you are working in the site, right?
Yes sir, yes sir.
किधर, कहाँ काम किया? Which site you are working?
Actually ओमान में हम काम कर रहा सर.
ओमान पे काम किया, इंडिया पे काम नहीं किया?
इंडिया पे एक्चुअली चेन्नई में काम किया सर.
चेन्नई पे काम किया. सो जेनरिक क्वेश्चन पूछ रहा हूँ, ऐसा नहीं. बेसिकली इंडिया में क्या होता है, मैं गेज 0.63 mm डिफाइन करके दे दिया, साइट में क्या होता है? 0.63 mm लेता है क्या?
Actually,
कॉन्ट्रैक्टर क्या करेगा? 50 mm का लगा देगा। वेरिएशन नहीं पकड़ सकता हमें। सो गेज नंबर 26 का डालता है वो। सो while working in the site, measure the quality check has to be done whether the sheet thickness is correct
0.63 or not. Yeah, in line with our requirement or not. Yes.
or not. You need to check it. Why? Because साइट पे यही काम होता है, क्योंकि when they buy in the cages, शीट और बॉट इन द केज, इतना केजी है, इतना टन है वो शीट, वो इतना टन के लिए मैं इतना पैसा देता हूँ। तब हम 0.50 mm का ले लिया तो उसका शीट ज्यादा आता है कंपेयर टू 0.63 mm का, क्योंकि थिकनेस बढ़ता है तो उसका वेट भी बढ़ेगा ना। ठीक है। तो ये रियल टाइम सिनेरियो में ये क्वेश्चन पूछता है। व्हेन वी से वी हैव एक्सपीरियंस, रियल टाइम सिनेरियो में ऐसा क्वेश्चन पूछने का चांसेस है। Yeah, Sandeep, any doubt?
No, I'm just learning, sir. This I don't know. So
Yeah. ठीक है। So while creating the duct, हमें next insulation. So insulation thickness, every material का एक एक अलग होता है सर, but standard insulation thickness as recommended insulation thickness 1 inch for the supply duct. Supply duct के लिए 1 inch, return duct के लिए 2 inch. आपका मन पे एक क्वेश्चन आ गया, सर उल्टा बोल रहे, सप्लाई को 2 होना है, रिटर्न को 1 होना है, राइट?
Obviously yes, sir.
Huh?
Yes, sir. Obviously yes.
Which one is right?
Yeah.
One first option or second option?
Actually, sir, 1 inch, 2 inch we use for roof, and supply and return both we use on same size only, sir.
Okay,
I think supply we need to use 2 inch, sir, because the cold air, right? Weight will be more, and also
yeah, I'll come to that point. So basically, supply के लिए 1 inch is enough. Why? Because we are supplying 18-16 grill temperature, 18 degree 16 degree तक होता है. Okay. Now, wait, sir, 1 minute. ओके, रिटर्न के लिए हमें 2 इंच डालना पड़ेगा। रिटर्न क्या होता है? रूफ में जाता है वो, रिटर्न का 24, 30, 31 ऐसा 30, 31 डिग्री सेंटीग्रेड ऐसा रिटर्न टेम्परेचर होता है। उसको हमें कितना प्रोटेक्ट कर सकता है, उतना रनिंग कॉस्ट हमें बच सकता है। सो रिटर्न टेम्परेचर शुड बी प्रोटेक्टेड मोर। व्हाई? बिकॉज वो उसमें कितना टेम्परेचर हमें प्रोटेक्ट कर सकता है, उतना रनिंग कॉस्ट कम होगा, क्योंकि रिटर्न एयर अगेन रीयूज, राइट?
yes.
So
Yes.
that is the reason. Okay, that is also one logic we need to have. And chilled water thickness of insulation for chilled water is 40 mm, and thickness for hot water insulation is 60 mm, and insulation material is puff polyurethane foam. Okay, chilled water is 60 mm, whether it is a supply or return. 40 mm is fixed. For return it is 60 mm. Sorry, for hot water it is 60 mm. Hope you are clear with that, right? So still any doubts you have?
For the insulation supply duct, what is the material, sir?
So it may be a glass wool. Okay, it may be a fiber glass wool, mostly same. Maybe nitrile rubber, maybe a XCP cross ethylene कुछ है उसको, XCP insulation मोस्टली हॉस्पिटल्स में यूज करते हैं।
XLP. Okay, fine.
Cross-link polyethylene. Cross-link polyethylene. XLPE, right? XLPE insulation that will be used in the hospitals mostly. Where fiberglass we can't use there. Next we have sometimes. So most वो ही use होता है. Glass wool.
In pubs, anything is okay, sir?
Where, sir?
Pub. Rubber is okay.
Anything. No, pub is applications में very easy. Fiberglass लेना है, which is cheap and which is best.
Okay.
So fiberglass use करने के time पे you need to be very careful. Why? Because when it touches to the skin, you feel more irritation.
Okay.
Why hospital में वो क्यों नहीं use करते ना? It will be have some layers.
Okay.
वो बाहर आने का chances होता है. So that is the reason. आजकल मार्केट में प्री फैब्रिकेटेड डक्ट्स भी आ गया सर. पहले हमें क्या करता था, पूरा डक्ट वी यूज्ड टू मैन्युफैक्चर ऑन द साइट.
Yes.
साइट में मैन्युफैक्चर करने का जरूरत नहीं है. वी मैन्युफैक्चर द डक्ट्स in the factory and they will be transferred to the site.
Okay.
So you give drawing, they'll manufacture and they'll give you.
Any factory, sir?
So in Hyderabad also we have 3 to 4 factories here. Duct ka.
Any particular factory, sir, you suggest?
I don't know. If you want, I'll give details.
Okay, sir. If possible,
I'll
just
provide you the details with that. I'll find and provide. Duct manufacturers in Hyderabad. There is one in GD Metla. Yeah. Okay. So still if you have any doubts?
No, sir.
Okay. So till here you are clear, right?
Yes.
So tomorrow we'll do the G+2 drafting. Drafting part will complete tomorrow. Okay. So first 1 hour I'll complete the drafting. Second 1 hour you need to work on it.
Okay, sir.
Okay. Later, day after tomorrow we'll go on static pressure calculations.
Okay.
Hope this concept is very much useful. Okay. This concept is very much useful when you are deciding the size of the duct.
Got it. Yes.
Shape of the duct. Okay. Oh, thank you everyone. We'll meet tomorrow.
Thank you, sir.
So whoever not completed your tasks till today, please complete it.
Okay, sir.
Why? Because again from tomorrow tasks will be going to add again.
Okay.
So by the end of these sessions, you need to be able to create a project report. Okay.
Yeah.
That's the intention. Clear?
Okay.
Okay. Thank you. Good night.
Thank you, sir.
Thank
Bye,
you.
Noor. Bye, Pranav.
Bye.
Bye.
Thank you.